Hello, everyone. I think we can start. Ladies and gentlemen, welcome to the fifth event in the series of webinars hosted by Green Growth Knowledge Partnership, GGKP. And let me extend my deep gratitude for registering and for joining today. My name is Anastasia Buchok, and I'm working for Component 4 of the Global NEP Update project. And today's webinar, Navigating the Production, Use and Trade of New POPs from 2009 to 2022, will guide you into a comprehensive overview of the total production quantities and historical production data of newly listed and relevant intentionally produced POPs. The webinar will also present the report titled Production, Use and Trade of POPs newly listed in the Stockholm Convention from 2009 to 2022. And we therefore sincerely hope this information will be helpful for your NEP review and update. And this is also to kindly remind you that our next webinar will be on Thursday this week, 1st of August, from 2 to 4 p.m. Geneva time, Central European Summer Time. And if you haven't yet registered, we'll promptly share the link in the chat right after. Finally, our webinar today will be conducted in English language. It would be recorded. Interpretation to Spanish, French, and Russian is available. We have 6 excellent interpreters working for this event, so please feel free to select your language in the bottom panel of the screen. And now let me give the floor to our today's speaker, Mr. Roland Weber, who has been in POPs environmental consulting for more than a decade, and I believe even longer in the research of POPs. So Roland will introduce you to the international databases, statistics, introduce the report. The floor is yours, Roland. Thank you.
Yes, thank you very much, Anastasia. Hello to everybody, good day. My name is Roland Weber, working since 30 years and doing research on persistent organic pollutants. And since 20 years now, nearly I support the Stockholm Convention, the Secretariat and different UN agencies, especially for inventory development, for guidance development, and also for national implementation plans. Today, the topic is production, use and trade of newly listed POPs from 2009 to 2022, and how to access relevant international databases and statistics. The presentation will be in 3 parts. Part A is on how to access relevant information on POP production, use and trade in international database, statistics and publications. Part B is then on the production, use and trade of new listed industrial POPs from 2009 to 2022. And this will include a part on brominated flame retardants, a part on the chlorinated new listed POPs, including short-chain paraffins and other chlorinated POPs, and a part on the per- and polyfluoroalkyl substances which are listed as POPs. And the last part of the presentation will be on new listed POP pesticides and their production, use and trade. So looking back since 2009, we have now 34 POPs listed, with 22 newly listed since 2009. 8 of them are pesticides. We have 5 brominated flame retardants, 3 groups of fluorinated POPs, and then the chlorinated POPs. And in 2023, we had the listing of 3 most recently listed POPs. This includes the UV328, which is the first non-halogenated POP, then the flame retarded Decloran Plus, and the pesticide Methoxychlor. So in this webinar, we will not address these 3 very recently listed POPs, but they will be also mentioned then in the next webinar on Thursday on the sectoral guidance. So first, to how to access relevant information on POP production, use and trade in international databases, statistics and publications. And the first one is the new guidance here and the report we developed over the last 2 years on the topic. So here the information on production, trade and use of a POP is quite crucial information for the control and for the management of POPs and for developing inventories. So if a POP is produced, then you will have the whole life cycle to be assessed and to be controlled. But many of these POPs are not produced anymore, and then only the production in use and the waste streams and the recycling need to be controlled. But for that, the information on production and production history and use need to be understood for the relevance of the different products to be inventoried and to be controlled. Therefore, this webinar is quite relevant. So this guidance is online on the Green Policy platform. Actually, the most recent one we just updated and uploaded today. It includes for each of the new listed POPs the current knowledge on production, use and trade. So here this document is a very good starting point for getting an overview on this information together with the presentation of today. And the presentation of today will give the main content of this guidance. Then a good data source are also the documents from POP Reviewing Committee. There you have documents developed for the proposal of listing of POPs for the Annex D POP criteria. There is the document on the risk profile for the Annex E evaluation and the risk management evaluation. And these documents contain also data on production and use, where you can also find, let's say, more details in respect on producing countries, for example. But over time, the status is changing. Yeah, for example, PFOS, which have been listed in 2009, the POP RC documents are from 2008-76. Yeah, and over time here, the information of production and trade becomes obsolete. So therefore, UNEP concluded that this document on production, use and trade is needed to include all the up-to-date information in one document. For the very recently listed POPs, this means Decloran Plus, UV328 and Methoxychlor, which are not included in the guidance, the recent information can be found in the documents of the POP Reviewing Committee, which are also still quite recent. And also for the chemicals proposed for listing as POP in 2025, this is the medium chain chlorinated paraffins and the long chain polyfluorinated alkylated acids. Recent information on production, use and trade is in that POP RC documents. Regarding exemptions for production and use, that information you can source at the BRS convention website. So here, the most updated information on specific exemptions and acceptable purposes and which countries are using and POPs and which are producing are included there. There are gaps in this registration, and I encourage all countries to register. One part of this registration here is the registration for the in-use of POPs in products. For example, the registration for the use of PBDEs in cars, or for hexabromocyclododecan or PFOS-PFOA containing firefighting foams in use in a country. So only a few countries have notified these uses. Also, almost all countries have, for example, vehicles in use on PBDEs, and also most countries in the world, for example, have hexabromocyclododecan in insulation foam, but today only Japan and China have registered for this exemption. So therefore, this report currently does not reflect the current use in the use articles. And I would like to encourage you to register also for the in-use of your POPs in products. Good information documents are the guidances which have been developed mainly by the BRS Secretariat. This includes the inventory guidances for the individual POPs, but web guidances and guidances on alternatives to POPs. And here, what you see in red, these are new guidance documents which have been developed now for the new NIP update by UNEP. This is the sectoral guidance on inventory of POPs, which will be presented next Thursday. And there are guidances on POP data sources in the country and databases that will be presented in October. And also a guidance is developed on quality assurance and quality control guidance, which will also be presented then in October. Then, as good data source, we have scientific publications. And I was quite lucky when I developed the production, use, and trade publication, because here in 2021, a review article was published by Professor Lee, and they have compiled all information on POPs production, use, and trade of all POPs in the Stockholm Convention until 2019. So here there are the data on production volumes over time, including information on production per decade. Yeah, you see here for all the POPs, the time frame from 1930 here until 2010s. And always for a decade, they have estimated the total production of individual POPs in that decade. So this data and information are also included in our guidance documents, and the details you can find in this publication. Also, this publication has large supporting information on how they concluded on these data. And then we just look to a few POPs here for the old pesticides, which are not relevant for our webinar here, but just that you see for aldrin, chlordan, chlordecone, you see that they have been produced here in the 1960s, 70s, and 80s, but already with decreasing concentration. You see here in the publication and also in our document, total amount which have been produced in history, and other chemicals to use here for PCBs, yeah, which you are managing since 20 years in your Stockholm Convention implementation. There are also the production started here in the 1930s at low concentrations, and then the main production was in the 1960s and 1970s, and already in the 1980s, the production has considerably decreased. But, you know, this information and understanding what amount of POPs have been produced in what decade and went into products is a very valuable and important information to understand what kind of products are impacted. Yeah, when we look here to the short-chain chlorinated paraffins, we see that until the 1980s, the production was relatively low, but then it strongly increased in the last two decades, and today the short-chain chlorinated paraffins with more than 9 million tons produced in history is by far the POP which have been produced and used most. And you see here it was most recently the main production, so therefore it's still in the products we have to assess and to manage. There are a range of further reviews on POPs in products. I will mention it in the presentation, and they are also referenced then in the guidance documents. Then when we look to trade, important area to get information is the UN Comtrade database. The UN Comtrade database are using the harmonized system codes, which includes more than 5,000 products and articles, and compile information here on the trade, import, export for approximately 200 countries, representing 99% of the world's trade. So this includes then the year, the flow, the products, and who is importing and who is exporting. And also for some POPs, there are specific HS codes where you can find then details in this Comtrade database. So for example, specific codes have been published and used for some pesticides, but also for PFOS and individual PFOS related substances like PFOS-F. And here you can directly check globally how the trade in the last 15 years have been. For other POPs, unfortunately, the HS codes were not specific, and also for PFOS before 2018 there were no specific HS codes. So when we developed in Turkey PFOS inventory, and that was by university, they have used at that time the unspecific HS codes, and the results from unspecific HS codes does not lead really to reasonable results. Yeah, so HS codes need to be specific, and the BIS Secretariat is working that more specific HS codes are established. Another problem in trade of POPs are that the POPs in products are not labeled. So here we have many HS codes for products which finally contain POPs. For example, much of the chlorinated paraffins are going into PVC, and then the PVC containing the chlorinated paraffins are traded. But unfortunately, it is not known what of these PVC which is traded contain a POP. Yeah, we have done a study and estimated for specific PVC products where we knew from studies in China about the concentration, the average concentration in the PVC, and there we have done an estimate how much of chlorinated paraffins are entering Nigeria. I will show you a slide later in the presentation. And then about the trade, there is also a recent publication from 2023 from Zhou in Nature Sustainability, and he has compiled recent review articles, compiled information on all hazardous chemicals listed in the Rotterdam Convention with the assessment of HS codes in the UN Comtrade. This includes information on the countries exporting and importing these chemicals, and in total they assessed 46 listed chemicals and concluded that more than 64 million tons of these chemicals have been traded between 2004 and 2019. One interesting conclusion was that about 25 million tons of these traded chemicals were illegal, mainly pesticides. So this is a very valuable study, and I will show also some data in this presentation. However, also this study has some inconsistency, and I also will show some of the inconsistencies. Yeah, but here you can see, for example, that's from the study from Zhou, and it's about DDT and the trade of DDT. So you see here, the major trader of DDT is India, and from India, you have major exports, for example, to China and to Zambia. Yeah, so this kind of data you can compile here from the HS codes. So this is clear from the production. But then also there was a DDT trade recorded between 2004 and 2019 from UK to the Netherlands or from France. So here, this trade is not for the product, but this trade is for management of waste. Because here, France and Netherlands, they have a large incineration capacity. So therefore, DDT gets exported from developing countries to other countries and finally also traded for destruction. This means HS codes can not only inform about, or do not only inform about the trade as a product, yeah, but also can cover here the waste which is moving. Yeah, but it's also interesting for you to understand and see these kind of data. Now we have a small poll from you, over to you, Anastasia.
Yes, thank you very much, Roland. And let us.
And also, Anastasia, if there are questions, and also,
There
let's
is.
say to the audience, if you have questions, I think we make now also a few minutes questions possible.
Sure, we do have one question, but I will first probably launch the poll. If you don't mind, I hope it works. Can
Yes,
you
it
see
works.
the question?
Yes.
Okay, please feel free to answer.
Yes. So the question is, have you evaluated the import of POPs to your country by UN Comtrade databases? So please check if you have evaluated no, yes, but rarely, or yes, frequently, or I do not know how to check this data. Okay, we come in, we have 18, 19 answers. We wait a little bit, 22 answers.
And while we are waiting for the answers, Roland, I think we do have one question from,
yes.
If I'm correct, from Macedonia, North Macedonia, if I'm not wrong. The question is there an open access to UN Comtrade data, or only officials can access this database?
No, everybody can access. So that's the big advantage. It's open source, yeah. Of course, you need to learn how to use it. But also in our document, we have a section about the UN Comtrade database with the links and more description in the guidance documents. Yeah, so you just can download the guidance documents, and there you get also a bit background on the UN Comtrade database and the HS codes.
Thank you very much, Roland. Maybe we can end the poll. I think we have almost 55% of response rate. So if you don't mind, I will complete the poll.
Yes.
And let me share the results. And I hope everyone can see the results. So 50% of respondents answered that no, they have not evaluated the input of POPs to their countries by the UN Comtrade database. 17% said that yes, but rarely. Only 3% answered that yes, frequently, and 31% of respondents said that they do not know how to check this data. So I hope that was very insightful, and I will stop sharing here.
Okay. Yes. And very important, I mean, to get an introduction to this UN Comtrade database, also then with the guidance, and also then maybe in a follow-up, maybe there could be later on a session on UN Comtrade database, possibly. Now we come to the second part. This is on industrial POPs, and we will start with the brominated flame retarded POPs. We have 5 brominated flame retarded POPs listed meanwhile in the convention. The most important are the polybrominated diphenyl ethers, both because of the high volumes they have been produced, but also because of their toxicity. So PBDEs have been widely used as additive flame retardants since the 1970s, mainly in plastics, in electronics, vehicles, and buildings and synthetic fibers. We have 3 different commercial products: the commercial penta-BDE, penta-brominated diphenyl ethers, octa-brominated diphenyl ethers, and the deca-bromodiphenyl ethers. So they are just a different bromination degree of this diphenyl ether. And looking here to the individual commercial mixtures. So here the commercial penta-BDE containing tetra, penta, hexa, and hepta. This has been produced to approximately 175,000 tons between 1970s and 2004. Yeah, this means since 20 years, no penta-BDE has been produced. And a very important information about the production and use is that 90% of the penta-BDE has been used in the United States. Yeah, mainly in polyurethane foam, but also on textiles and printed circuit boards, for example. So in the listing, there was no exemption for production and no exemption for the use, but there is an exemption for recycling of products containing penta-BDE. When we look to the octa-bromodiphenyl ethers, which contain hexa-bromodiphenyl ether and hepta-bromodiphenyl ethers listed in the Stockholm Convention, about 130,000 tons have been listed. This has most commonly been used as flame retardant in ABS plastic, which is a major plastic used in electronics and in transport, but also in construction. Also in some other plastics like high-impact polystyrene, HIPS, which is used in electronics, and some further plastics. So also here, in the listing, there was no exemption for production and use because the production already stopped 2004. But also for octa-BDE, there is an exemption for recycling of articles and of the plastic. Then the last commercial product and the most important one from volume is the deca-bromodiphenyl ether. About 1.6 million tons have been produced, and the production is still ongoing. You can compare this, for example, with PCB. In total, about 1.3 million tons of PCB has been used. So here you see more deca-BDE has been used than all PCBs combined. And for the deca-BDE, there is an exemption for production and use, a range of exemptions for the uses. And when we go now into the review on the production, you see here over the decades what commercial mixture have been produced and used in which decade. So you see, yes, here in the 1970s, the small production started, increased in the 1980s, 1990s. And here for the commercial penta-BDE and commercial octa-BDE, already in 2000, the production and use has decreased with no production here in the 2010s. Yeah, while for the commercial deca-BDE, the production also started in the 1970s, strongly increased, and the major production was between 2000 and 2010. Yeah, and then a strong decrease in the last 10 years, and now in 2023, also the production of deca-BDE in China has stopped, and only at the moment it's considered that India is producing, but also probably at quite low level. Yeah. So by this figure, you understand which products are mainly impacted, yeah, which plastic products like electronics, vehicles, yeah, and so on, by the PBDEs. And in total, we have 1.9 million tons of PBDEs when we combine all the 3 commercial products. And when we consider that in average, they have been used between 5 and 15% in products, so we say an average 10%, then we can estimate that in total, we have about 19 million tons of PBDE containing plastics, which have been produced. Yeah. And then from this time resolved, we understand what kind of plastics have been impacted, and then what we need to really understand their current use, their waste management, is the service life of the different products. And what you see here in the figure from Abbasi et al. Is the total use of DKBDE and OCTA-BDE here in the major applications. Yeah, here when you look, for example, the DKBDE use in electronics, in foams, in construction, in transport and textile, you see that DKBDE has been used nearly equally in these products. Yeah, while when we, for example, go to the penta-BDE, we see that around 50% have been used in polyurethane foams. Yeah, going into, for example, furniture or also into transport. So then an important number is the average lifespan. Because, for example, OCTA-BDE has been used until 2004, right? But if you have electronics with an average lifespan of 7 years, more or less all products of OCTA-BDE has already gone to the waste management. Yeah, when we take another use area, for example, transport, the vehicles, where we have an average lifespan here of a car of 15 years, then we understand, okay, for cars, these chemicals which have been used the last 20, 30 years maybe are still around. And what we have seen, for example, for developing countries in Nigeria, we have seen that the average lifespan of a car is more than 30 years. Yeah. So here then for vehicles, for example, in Nigeria, still many of the PBDEs which have been used in vehicles in the 80s and 90s are still in use. Yeah. So, but then we have the service life of the construction, which is even longer. Yeah, here they tell 30 years, but it can even be for insulation foam, it can even be 40, 50 years. So we understand that the PBDEs which have been used in construction are still there. And when we look here to the different percentage which have been used in the different uses, we understand, okay, maybe most of the PBDEs today are not in electronics, yeah, but in vehicles and end-of-life vehicles and in construction. Yeah. So for hexabromocyclododecan, this is very different application and the use. We will come later. So here 90%, for example, was in construction. We will come later to the detail. Then DKBDE is still produced and used, and the exemptions are additives in plastic houses, parts for the use in vehicles and in aircrafts. Yeah, this means also 2 uses which have long time uses, and 2 exemptions have recently been stopped and expired. This is for textiles and polyurethane in building insulation. Yeah, so these were, let's say, the major uses in the recent years, yeah, of DKBDE. And what you see here is a material and substance flow analysis of PBDEs in the different uses in the US and Canada. Yeah, so here I just introduced to the electronics. Yeah, here you see for the electronics where the total stock was increasing since the 1970s, and around 2005 we had the peak here of the use, and then because of the relatively short lifetime of electronics, by 2020 for the United States and for Canada, it's estimated that already most of the electronics have gone out into waste. When we look here to the automotive, we see about the same amount have been used in automotives compared to electronics. But because of the long service life, today there are more PBDEs still in use in vehicles compared to electronics in the United States. Yeah, but this with the different service life I mentioned for you to the developing countries are quite different. And therefore, for the sectoral guidance next week, we have developed materials and substance flow analysis here for Nigeria, yeah, as another example. While our webinar today is on production, trade, and use, in one slide, on the total life cycle of PBDEs, I would like to highlight here and make one addition. And this is that today we do not need only to focus on products, but also we need to look to recycled products. Yeah. So recycled products are not the focus of this presentation, but when we are now talking about circular economy and recycling of plastic with the plastic convention upcoming, yeah, recycled products are also important. Coming now to the fourth flame retardant listed, this is hexabromocyclododecan. So here the production stopped recently in 2021. The last production was in China. I already said 90% of its use was flame retardants in polystyrene foams for insulation. At the time of listing in 2013, this was also exempted for production and use, but this exemption stopped because it was listed in Annex A, and therefore the last production was in December 2021. So in total, 700,000 tons of HBCD have been produced. So therefore also HBCD after the DKBDE is the second most produced brominated flame retardant POP we have. And today, with the stop of production, there is no trade, but because 90% have been used in the polystyrene insulation, we can calculate in average about 1.5% of HBCD has been used in polystyrene. So we can estimate that we have about 42 million tons of EPS, XPS in construction, which is still present in insulation foam and is one of the largest POP stockpiles in the world. Yeah. So the service life of polystyrene insulation is 30 to 50 years and even longer. So therefore, it will be a long-term management of these POPs and the insulation foam in future. I show here to you another material and substance flow analysis of Beijing University, Dr. Li. I was also part of that study. So what you see here is the increasing use of HBCD and the stop of HBCD use here in 2020. But at the same time, this HBCD is insulation foam. And what you see here in the second curve, this is the estimate of the waste of EPS and XPS going out of construction and going into landfills and waste management. And what you see here is the time frame until 2100. So still in 75 years, there will be HBCD in EPS, XPS going out from construction and demolition. Yeah. So very interesting perspective and very important for the management. The last brominated POPs is hexabromobiphenyl. That's an easy one. It was only produced in the United States from 1970s to 1976, about 5,400 tons, so very small volume. And because the last production was around 50 years ago, more or less all of the products have already ended end of life. Maybe with the exemption of some classic cars from the United States, because the main use was in the United States from 1970s to 1976. Yeah, when it was listed without exemption. When I prepared the guidance and I looked to that publication on production and trade, I saw that the authors thought from the data in the Comtrade database that there has been reasonable trade of HBB hexabromobiphenyl between 2004 and 2019. but the production stopped in 1976. And actually, in all the monitorings, and there were many monitorings of plastic, recycled plastic, and so on, nobody has ever detected hexabromobiphenyl. So therefore, something was wrong in this data set. And I think what was wrong is that also hexabromobenzene, with the same abbreviation HBB, is produced and used as a flame retardant. Yeah, and therefore there is export and import of HBB, but this HBB is not hexabromobiphenyl. This is hexabromobenzene. And when we look to the countries, the best country with the best database of the production and use of brominated flame retardants is Japan. Japan, since 2004, they have published their use and production of brominated flame retardants over the time. So it's a super database. And what you see in this database of Japan is that they are using hexabromobenzene, yeah, but they are not using hexabromobiphenyl, yeah. So here I think that publication mistook these HS codes, or even more probable that the people which are sending that chemical might mistook the name and then register under hexabromobiphenyl. Okay, coming now to the chlorinated POPs listed in the last 15 years. Short-chain chlorinated paraffins listed 2019 with a range of exemptions. Medium-chain chlorinated paraffins, this will be listed in 2025 with a range of exemptions. And then we have three more chlorinated POPs, which are hexachlorobutadiene, pentachlorobenzene, and polychlorinated naphthalines. So the most important there, as you have already seen, is the chlorinated paraffins, because they are produced in huge amounts. Short introduction, short-chain chlorinated paraffins has a carbon chain of between 10 and 13. Medium-chain chlorinated paraffins have a carbon chain between 14 and 17. And long-chain chlorinated paraffins have a carbon chain of longer than 18. And these chlorinated paraffins are produced with different degree of chlorination, and often producing countries like especially China and India, they describe the different products not in respect to the chain lengths, like short and medium and long chain, but rather on the chlorination degree, and sell 30% or 50% chlorinated paraffins. So, but with this variation, we have around 200 commercial chlorinated paraffin formulations in use. The Stockholm Convention listed short-chain chlorinated paraffins with a chlorine degree of more than 48% as a POP, but also chlorinated paraffin mixtures, which contain more than 1% of short-chain chlorinated paraffins, are already considered POPs. Yeah, so it does not need to contain 100% SCCPs, but already at 1%, 2% of a mixture, that chlorinated paraffin mixture is already considered SCCP and a POP. For the medium chain chlorinated paraffins, for the listing, it is proposed for chlorine content more than 45%, and that will be discussed at the next COP in May 2025. It is still produced, and frequently short-chain chlorinated paraffins is in mixture with medium-chain chlorinated paraffins. And the estimate over the last years was that every year around 400,000 tons of short-chain chlorinated paraffins, or rather 900,000 tons of mixtures of short and medium-chain chlorinated paraffins have been produced, mainly in China and India. So China has restricted the production of short-chain chlorinated paraffin in December 2023, but in the listing, there was a large list of exemptions for production and for use, but this exemption have stopped by December 2023. But it will take some time until productions, for example, in China will switch, and India has not ratified yet short-chain chlorinated paraffins. So therefore, most probably for the years to come, there will be also short-chain chlorinated paraffins. What you see here is a review article about chlorinated paraffin productions in the last 100 years nearly. So you see the production started in the 1930s, but the huge production and the increase of production especially came after 2000, when China and India started large-scale production. So here today we have a production, or since 2010, above 1 million tons per year. This means chlorinated paraffins are produced per year in the same amount like PCB in history. And when you look to the global production capacity of chlorinated paraffins, today we have around 2 million tons of production capacity, which is not fully used. So it is estimated that we have at the moment maybe around 1.4 million tons of chlorinated paraffins produced. And like I said, short chain chlorinated paraffins is around 20-30% of that. The major use are medium chain chlorinated paraffins, and then some long chain chlorinated paraffins. Other productions we have, for example, in Egypt, Russia, Qatar, South Africa, and United States, but at lower levels, and some have restricted short chain chlorinated paraffins since many years. When SCCPs have been listed, then many exemptions have been accepted. This include flexible PVC in the use in rubber transmission belts and rubber conveyor belts, in leather industry, fat liquoring as lubricants, in metal processing, waterproofing and fire retardant paints, and also in adhesives. But these exemptions for SCCP have expired. So therefore, assessment is needed in current use, because I think it's still produced. And when now MCCP will be listed at COP12 in 2025, the similar or same exemptions are expected and are proposed for medium chain chlorinated paraffins. And after listing with the exemptions and so on, we will have at least production until 2031 of medium chain chlorinated paraffins. So also this is a work for the next decades. Important also here again for the chlorinated paraffin are the main uses, which I have shown before for the PBDEs. So the best study again comes here from China, from Chen et al. From Beijing University. So they have analyzed 124 products in the major uses like PVC, rubber, polyurethane spray, but also they have analyzed paints and metalworking fluids. And what they have found that in China, more than 70% is going into PVC. More than 10% is going into rubber, more than 10% is going into polyurethane foam. And then the other uses are relatively small. So this means that especially PVC is a major, let's say, source also for future management of chlorinated paraffins worldwide, because this PVC is then exported from China, from India to other countries. Plus, there's of course also some export of chlorinated paraffin mixtures, especially from India into other countries. And for example, also we have found, for example, in Brazil, that a big part of the chlorinated paraffins is going then to PVC and to rubber production in Brazil. So this review of Chen et al. Have compiled the cumulative production of chlorinated paraffins, and it's estimated to more than 33 million tons of technical CP mixtures, including more than 9 million tons of short-chain chlorinated paraffins and about 19 million tons of medium-chain chlorinated paraffins. And when you look here, this is the major global use, the estimated from that research group. So they estimated that about 60% of all chlorinated paraffins have ended in PVC, 15% in rubber products, 15% in lubricants and metalworking fluids, around 6% into sealants and adhesives, and around 4% into paints and coatings. I think it is a good estimate, but they did not have data from India because there are no data from India, yeah, on the use. So therefore, I think that, for example, in this estimate, the use in leather and in paints is underestimated. Yeah, so here we need data from India to understand and refine this assessment, but it is a first good guess. Also, what you get for chlorinated paraffins in your countries in the imports. This is a study from Europe, because this PVC and this rubber are then in normal commercial products. So here in Europe, they have done an assessment from 2015 to 2017-18. What products are above 1,500 milligram of short-chain chlorinated paraffins? And what you see here, toys, plastic dolls, toy doctor sets, bouncing toys, stickers, rubber knife, toilet seats for children. But most of these are either PVC or rubber. Yeah, sports equipment, beach ball, baseball gloves, fitness gloves, yoga mats, all-purpose mats. Yeah, oven, PVC, rubber, or some other plastics. Yeah, so you see how these products from production of the paraffin finally into products, PVC, rubber, come into our normal commercial use. I give you two further studies which I think are interesting. The first one is on kitchen blenders, a study in Sweden and in China. So they have analyzed normal kitchen blenders, and they found that 8 of 12 of these kitchen blenders contained high levels of chlorinated paraffins and were directly releasing the chlorinated paraffins into the food. And what was interesting is that these release from these blenders did not decrease even after use 5 times and 10 times. So here the chlorinated paraffins are either in the plastic parts, which have a slow release, or Dr. Zhanyun Wang from ETH told me that there are some special porous metals in this equipment which contain then the chlorinated paraffins as a lubricant. And it is on purpose that this lubricant is only released very slowly, that this equipment is smoothly working. Yeah, but here we have a direct exposure from a product into humans. Another very interesting study from Professor Vetter, here from the group in Hohenheim University, they found that they had high levels of chlorinated paraffins in kitchens, and they did not understand why. And then they started to analyze different kitchen equipment, and they also analyzed 20 baking ovens, German baking ovens. And what you see here, that 50% of the baking ovens contain unbelievable high chlorinated paraffins in the indoor. This means they only did a wipe test of the baking oven indoor. And so here the chlorinated paraffins have been used in cables at concentrations in PVC cables, in concentrations of 10 to 15% of PVC. And when you heat up the baking oven, these chlorinated paraffins come out of the PVC cables and directly go into the baking ovens. Yeah, and they did another study about food, and they found that these chlorinated paraffins then move here from the baking ovens to the food. Yeah, what is interesting here, these are the PBDE levels of the baking oven, and what you see here, that for most of the baking ovens which did not have chlorinated paraffins, you found, but at much lower levels, PBDEs. So it seems that here the chlorinated paraffins were used as flame retardants in the cables, while here for these baking ovens, the PBDEs have been used as flame retardants, for example, in cables. Yeah, very interesting study. I recommend to look. So Chen et al. Also did a complete compilation and estimated how much of the historical used chlorinated paraffins are still in use. And here is their assessment. So they estimated that today almost all, more than 70–80% of the chlorinated paraffins which are present in PVC. Yeah, some are present, they estimate it present in rubbers, and some in these sealants. So the reason is that, for example, lubricants and metalworking fluids, yeah, you are using and you are releasing. While for PVC, when it comes into, for example, floorings or other uses in construction, they stay long time. Yeah. So therefore, when we look today to the total, let's say, stock of chlorinated paraffins, most of them are in PVC and some in rubbers and in paints. And so their estimate of this around 13 million tons, which are still in use, you can estimate that when you consider that they are contained in, for example, 10% in the product, that the total amount of product is 10 to 100 times more. This means we are talking about a stock of POPs containing short-chain chlorinated paraffins of at least 130 million tons of products. Yeah, mainly PVC and rubber. And this is one slide because, yes, we had for 6 weeks another webinar, and I said, yes, there is now, with the new industrial POPs, a very close link between POPs and plastics. And what you just saw here, rubber is also a plastic, with the PVC and the rubber, but also with the use of PBDEs. The issue of these industrial POP is mainly plastic. And the management of these POPs is at the same time mainly management of these plastic products. Yeah, like I said, the 13 million tons of SCCPs are present probably in 200 million tons of PVC, rubber, and polyurethane foam products. Every year we get more than 1 million tons of chlorinated paraffin mixtures in, let's say, at least 10 million tons of polymers. And when you look at these waste categories and when you consider that the Basel Convention provisional low POP content, the lowest low POP content, the proposed low POP content is 100 milligram per kilogram, then probably more or less all the soft PVC, when you would do now in Africa an assessment of the soft PVC in the end of life, probably most of this soft PVC, I would guess, is above 100 milligram per kilogram. Yeah. And then we are not talking about this 100 million tons, then we might talk about billion tons of PVC and rubber waste above the low POP content of Basel Convention. And then in addition, we have the plastics from electronics. So in total, we have about 62 million tons of e-waste every year. This 62 million tons e-waste contain around 12 million tons of e-waste plastic. So, and this 12 million tons can contain then the POPs, the PBDEs, the HBCD, but also others POPs like UV328 and Decloran Plus. Yeah. Similarly, the plastic and polymers from end-of-life vehicle, we can estimate per year to 10 to 20 million ton, which contain POPs at lower levels compared to e-waste. Yeah, sometimes they are below the low POP content of Basel, but still it contains these POPs which need to be separated and managed. Yeah, so these are huge POP containing plastic volumes which need global environmental sound management to prevent the littering in the world with plastics and POPs. And so here I think that there is a very good synergy for the upcoming Plastic Convention and the Stockholm Convention to solve this issue. And one challenge is that these plastic contain halogens with their challenges to do end-of-life management and destruction. A good news is that we have already CHEF projects on these flame retardant additives. For example, HBCD phase out in China project. Also, Turkey has a project on HBCD, which include end-of-life management. We have e-waste plastic management in Ghana, Nigeria, Ivory Coast. And I hope that the lessons learned from these can be used then also for other countries when they manage their plastics and the POPs in these plastics. I have tried to do an overview figure. These are different plastic types. Yeah, you see polypropylene, polyethylene, polystyrene, PVC in the different applications. And here then the major polymers in the major applications. And it is clear only a small part of these plastics contain POPs. For example, when we look to packaging basically don't include POPs, yeah? But here, the building, construction, and automotive, electronic sector contain POPs, yeah? But also there, for example, in the electronic sector, it's mainly the ABS and the polystyrene, the HIPs, which are containing POPs, yeah? But this is a first rough, let's say, to give you an idea that it's not all plastics which contain POPs, yeah, and that we really need to do more monitoring. Yeah, here, for example, building and construction, you see here for the polystyrene, this is the EPS and XPS, which is largely flame retarded with hexabromocyclododecan. Yeah, so you see here a large part of this polystyrene contain at the same time POP flame retardant. Yeah, I think we need more measurements, but I think this slide which I prepared for this presentation is quite useful. Then to the trade, SCCP are listed in Annex 3 of the Rotterdam Convention and should be subjected to the prior informed consent. However, it's unclear if this procedure is used by exporting countries. Yeah, so China has only recently listed SCCP, and India also have not registered for SCCP. So probably they might not do the prior informed consent. And maybe that's a question to the audience. If anybody here in the audience had ever prior informed consent for SCCPs, because this has been traded since in the last 7 years of listing in millions of tons. Yeah. So unfortunately, the HS codes are not specific for SCCPs and are also even not specific for the class of chlorinated paraffins. Yeah, we know under which HS codes it's traded. We know, for example, for China, yes, that most of the chlorinated paraffins are going to PVC and rubber and polyurethane foam. And what we have done then for Nigeria was that we have done an estimate how much of chlorinated paraffins based on data from China has been imported to Nigeria in the past. Yeah, I show you it in the next slide. But one conclusion of this paper is that we need a significant improvement of the Rotterdam Convention in respect to the trade of industrial POPs, especially industrial POPs in products. So that's the result of our assessment for Nigeria. So what you see here is the import of PVC and rubber and polyurethane foam from China to Nigeria the last 20 years, more than 20 years. And we have estimated that in total, more than 37,000 tons of chlorinated paraffins have been imported in mainly PVC, rubber and polyurethane foam. And for the medium chain chlorinated paraffin, which is produced at higher levels, we have estimated that close to 60,000 tons of chlorinated paraffins have been imported to Nigeria unrecognized in PVC and rubber products. Yeah. This is a quite reasonable estimate. Also, when you consider the per capita use, there we are still a factor 4 lower than the average use of chlorinated paraffins per capita. And when you look to the human milk in Africa, they have the highest levels of chlorinated paraffins in their human milk. And most probably this comes from the import of these kind of products used then in construction. Then shortly to the other chlorinated POPs, hexachlorobutadiene, pentachloropbutadiene, and PCNs. They are not that relevant for the management. For PCNs, they have been produced to around 150,000 tons, mainly between 1930s and 1960s. There is current one production. This is in Russia for the exemption to produce polyfluorinated naphthalines. This means it does not go really into products, but it goes directly in the production of polyfluorinated naphthalines. So here there is for the production this exemption for Russia and also for the use of this exemption. And since PCNs have been mainly produced from 1930s to 1960s, most products containing PCNs have been disposed already. So only a few capacitors and cables with very long service life might still be there. Since PCNs have been used in the same applications like PCBs, this includes capacitors and, for example, also cables where PCBs have been used, but also in paints. So therefore, in the management of open applications of PCBs and closed applications of PCBs, also PCNs are managed. And now we have the short-chain chlorinated paraffins, which have substituted PCNs and PCBs. So therefore, when you will do inventory and assessment and management of SCCPs at the same time, you will manage the remaining PCNs and PCBs in these applications. Trade, no trade is considered because in Russia, the production of the PCNs are directly going in the production of PFNs, so there is no export of this. Also, for the pentachlorobenzene, there's no production since more than 20 years. It is unintentionally produced. The same for PCNs. PCNs is also unintentionally produced. The past use, for example, was in transformer oils. So still in PCB transformer oils, sometimes there is pentachlorobenzene. Yeah, so there were transformers contain 70% PCBs and around 30% of some others like pentachlorobenzene. So there you might find, but then also manage it together with the PCBs. Also, there was no exemptions in the listing, not for production and not for use. Hexachlorobutadiene is also mainly an unintentional byproduct in the production of chlorinated solvents. And here in chlorinated solvents, sometimes huge amounts of hexachlorobutadiene has been produced as byproduct. And there was then some separation and commercial use. But this for the OECD countries stopped already in the 1980s. It is unclear if in some low and middle income countries which are producing chlorinated solvents, this is still separated. A few years ago, I have found that there were some vendors still offering hexachlorobutadiene, and there is still one or two in the internet when you check. Yeah, but I don't know if this is still real or if they still have listed it. Yeah, but for hexachlorobutadiene, there is no exemption for production and no exemption for the use. Coming to the very last group of industrial POPs, these are the three groups of the fluorinated POPs, PFOS, PFOA, and PFHexS and related compounds. So interestingly, at the moment, also long-chain acids were assessed by the POP reviewing committee and are proposed then for listing. So you see, these are a very important group now to address and very challenging to manage. In respect to production and use, we know for PFOS that around 96,000 tons have been produced, but the production have stopped likely in 2022. Yeah, so probably also the trade has stopped, and I will show you in another slide while this is probably true. When it has been listed in 2009, it was listed with exemption for the production and a wide range of uses, and it has been listed in Annex B. This means not only specific exemptions, but also acceptable purposes. And in 2009, a long list of acceptable purposes have been listed. And from this list, now only insect bites for the leaf cutting ants in South America is still acceptable purpose, while the others like metal plating, firefighting foams, etching, aviation hydraulic fluid as acceptable purpose is not acceptable purpose anymore, but some of them have moved to specific exemptions, including the plating industry. So today, for the specific exemptions, we have only hard metal plating and firefighting foam use, which is still allowed, while all others exemptions, including the use in carpets, paper, textiles, and so on, they have stopped exemption. What is nice with PFOS, since 2017, there have been specific HS codes, and therefore the PFOS trade should be controlled. So these are now some data from the HS codes from PFOS and trade and PFOS related chemicals. So what was interesting is that in between 2017 to 2022, when you put together all imports of PFOS, these were 3,350 tons. When you put together from all countries the total exports, it was only 604 tons. Is this possible? Yes, because you are not supposed, so there is no legal requirement that you need to report. This means that some countries are not reporting their export. Yeah. So you can check major exporting country, for example, is China, but normally China is not reporting the export of PFOS. Yeah. So therefore here, when you detail look to the HS codes, there is an imbalance between imports and exports. Reporting to the HS code is voluntary, so it is also legal. Yeah. It is a little bit unfortunate. Yeah. And I think it would be nice if countries, especially here for the POPs, report to the HS codes to get a better overview for the flow. These are data here for PFOS F, yeah, a precursor of PFOS, and the precursor or product where you produce other PFOS precursors, and where you see here you have a large import to Brazil from 2017 to 2020. Brazil was importing 31 tons per year, mainly from China. This was acceptable purpose. In 2021, 35 tons, and this has sharply decreased by 2022 to 9.2 tons. And like I said, the information from China was that in 2022, the production was stopped of PFOS in China, and actually there is no any import of PFAS to Brazil since then. So no import in 2023 and no import in 2024. Yeah. So it seems that also the production stop in China is real, and also that the stocks have been exhausted. I would highlight one more data here from PFOS here. What has been found is that Netherlands have imported 2,500 tons of PFOS from 2017 to 2021. And this is actually 5 times higher or 3 times higher than the total production volume of PFOS. So how can this be? Probably the reason is that the import here was rather firefighting foam for destruction. Yeah, because in firefighting foam, it is contain PFOS, so it can be reported as PFOS, but it only contain 1% of PFOS. Yeah. And here, Netherlands has a good destruction capacity, is accepting hazardous waste globally. And I think that this is the most probable reason why we see a high import of this PFOS to the Netherlands since 2017. When we look to PFOA, about 9,500 tons of PFOA has been produced from 1950s to 2020, and more than 170,000 tons of a specific PFOA precursor, which was mainly used in side chain fluoropolymers. Yeah. So therefore, overall, the PFOA production was probably more than the total PFOS production. Yeah. Also relatively high, and PFOA is still produced. It is allowed to be produced, and it has been listed with a range of exemptions. So here are the exemptions. This includes textiles, medical devices for the production of fluorinated polymers, but also for photolithography and photographic coatings, and also for firefighting foams. But for firefighting foams, not for the production for new firefighting foams, but the use of old firefighting foams is still allowed. This means existing stocks. And when we look to today's production, and I do not have a share of P4R production, unfortunately. The only what I have found which is most close is the production of fluorotelomers, because some major fluorotelomers are P4R precursors. This means the 8,2-FTF, FTOH, and the 10,2-FTOH. When they degrade and oxidize, then they are partly converted to P4R. Yeah. But there are also other fluoropolymers, fluorotelomers, which are, sorry, which are not P4R precursors and which are not restricted under Stockholm. And you see here, the main use is in textiles, another major use in firefighting foams, in food packaging, and repellent coatings. Yeah, so today these are major uses, probably also of P4R precursors. Then to the last POP, PFAS. This is the PFXS. Also here the production stopped. The former production was much lower compared to PFOS. Also there is no trade of the substance. Possible there is still trade of some firefighting foam containing the PFXS. When it was listed without exemption for production and without exemption of use. It has been used in the same application like PFOS before, like firefighting foams, metal plating, textile coatings, polishing agents. And while there is no new products on the market and which are entering the market, still maybe some products like firefighting foams produced 5 years, 10 years ago might contain PFXS. And PFXS has not only been intentionally produced, but also unintentionally produced. So in PFOS products, normally PFOS products contain around 4 to 14% of PFXS. Yeah. So this means you have a PFOS firefighting foam, and this is this picture. So here you see 5 examples of PFOS firefighting foams from China, but the production here is 2013. So this is not recent. This is more than 10 years ago. But when you analyze here the details of these firefighting foams and the PFAS content, you see and you find also PFXS, yeah, but in a concentration of some percent, maximum 10%. Yeah, so therefore still some PFXS might be in use and mainly here as a co-pollutant. Okay, so that was the overview on other industrial POPs, the brominated ones, the chlorinated ones, and the fluorinated ones. And we can come, Anastasia, to the second poll, and then you can also ask the questions which came up until now.
Thank you very much, Roland. Just give me 1 minute. I will launch the second question while we are waiting for questions from the audience. So our second question is, should POPs in products or articles be labeled that trade of products could be better controlled? And the potential answers is yes, this should be legally regulated, or this could be voluntarily regulated by industry, or no need for this regulation. So please feel free to answer, and also please leave your questions in the chat or in the Q&A module. We are really happy to answer. We had some of the questions in the Q&A, but those were mainly related to sharing the presentation. So once again, we will share the presentation materials. We will also share the links to the report presented today, and also the links to other publications by Dr. Roland Weber. And of course, we'll share the video recording of this event in all of the languages by email with all participants by the end of this week. So hopefully. Okay. Roland, do you think we should wait a little bit more for the answers? Or
Yeah,
shall
but I
we
think it's quite clear. Yeah, I mean, more or less everybody except of one. So it seems there is one person which think, okay, it might be possible to voluntarily regulate it, but you see here 93 out of 40 answers, mean 89% are stating that this should be labeled, yeah, POPs in products. I also agree. I mean, we had, at least in the listing of hexapromocyclododecan, we had a kind of labeling, yeah, for products containing HBCD, and I think it was a good idea. There was also in the last COP, in the listing of UV328 and in the listing of Decloran Plus, a long discussion, especially countries from Africa, developing countries, they wanted that also for the listing a labeling would be required, because otherwise it is more or less impossible to control these products after they have been put into electronics without labeling. Okay, so we can, I
Yes,
think,
I will
stop that call,
sharing.
so that's clear.
And over to you, Roland. Thank you.
Yeah, yeah. So then we come to the last part. It's a shorter part. It's on new listed POPs pesticides. Like I said, we have 8 POPs pesticides listed in the convention since 2009. They have very different relevance considering their total production and the differences in use. And all of these pesticides can occur in stocks and obsolete pesticides and are managed together. This means when there is one more pesticide which is not produced anymore, you anyway manage it within the pesticide stockpiles you are managing. But then there are some which have some specific issues, and I will come to it, especially here for pentachlorophenol, which is not only used in agriculture, but which has major use also here for the wood treatment. Pentachlorophenol is also one of the big POPs. So you see the estimated total production is more than 2 million tons produced in history. It has been not only used in agriculture, but in wood, in textiles. A large use was also in leather. Currently, only the use in wood is allowed. So when it was listed, the exemption was for utility poles and for cross arms. And when we look here to the historic production of pentachlorophenol from the study of Lee et al., they estimated that the largest use of pentachlorophenol was in the 1980s and already decreased significantly to the 1990s and 2000s. I agree with 1980s to 2010, but I think that the group is underestimated the production in the 1970s, 60s, and 1950s. Yeah. So therefore, I think here the 2.1 million tons over the last 90 years is rather a low estimate. But when I look to Japan, Germany, other countries, I see that especially in the 1970s, pentachlorophenol was used in huge amounts. So it might be even higher. So Mexico has had registered PCP production that was about 6,800 tons. But this exemption for Mexico ended in 2021, in December 2021. And to my knowledge, Mexico, because there is no exemption, that Mexico has stopped the production. Yeah, it was only using a minor part of it. Most of this production went to United States and to Canada, which were heavily using pentachlorophenol in the wood treatment. So also Canada was one of the countries which were asking for this exemption for the wood poles. And still we have some pentachlorophenol production in India. India is here as an Article 25(4) countries, has not ratified the pentachlorophenol amendment, and therefore does not need to register and does not need to report what is the amount. But at the moment, India is doing an update of the national implementation plan, and I am sure that the team is also looking to the pentachlorophenol production. So we know that we still have a use for the wood poles. We do not know the use of pentachlorophenol in India. When we look to the service life of products which are treated by pentachlorophenol, we also see that for the wood, a considerable share of wood treated over the past 30-50 years are still in use, while from textiles and leather, which have been treated in the 1950s, 60s, 70s, 80s, probably a large share has already gone into waste management and into landfills and incinerators. The wood has very long service life, up to 100 years for timber wood used indoor, and longer. I mean, in Germany, we have houses from the 15th century. This means 500, 600 years old. Yeah, and still the wood which have been used in these houses is still there, often. And then we have the second life of this kind of treated wood, because it is high quality wood. For example, the railway sleepers, and also in Germany, even Switzerland, these railway sleepers in the 1980s, 90s have been reused. Yeah, and I just give you here two examples: the reuse here for furniture, or here the reuse here for gardening, where you then get a direct exposure from the skin, or here from the plants and salad you grow, from this reuse of the pentachlorophenol treated wood. And since pentachlorophenol was one of the largest source of dioxins in history, these highly dioxin contaminated products also have a relevance for exposure for dioxins here indoor. Or for example, in America was a study of meat in early 2000s, and all the meat which contain dioxins above European regulatory levels of today was raised in stables which was treated, wood stables which was treated with pentachlorophenol. Yeah, so you see, therefore, when you are managing and talking about pentachlorophenol, you also need to think about dioxins and include it in the dioxin inventory. When I developed the guidance document, then I saw in the publications of Zhou et al. With assessment of the global trade of POPs and other Rotterdam chemicals, that they have estimated over the last 15 years, more than 50 years, that there was a high trade of pentachlorophenol. And I showed you before, what I knew, or what we know from the Stockholm Convention, is that by 2019, there was only Mexico with about a production of 6,000 tons, right here. Yeah, and India, we don't know, but mainly they are using it themselves. So then I looked into details of that study. And what I found is that Zhou et al. Has included two HS codes, yeah, 290811 and 290819. And the 290819 was the major HS code which indicated export of pentachlorophenol from the United States, from Israel, and from Jordan. Yeah, actually, when I prepared the guidance and saw this publication, I sent an email to the focal point in Jordan and an email to the focal point in Israel, and I said, look, what is this? Do you really have pentachlorophenol production? Yeah. But when I looked into details of the HS code, the HS code 290819 says containing only halogenated substances of phenols and phenol alcohols, but excluding pentachlorophenol. So these are other phenols. And this includes, for example, tetrabromobisphenol A. So that's also a phenol. And this is the major brominated flame retardant produced in the world. And this flame retardant is mainly produced in United States, Israel, and Jordan. This means what Zhou and al. Had assessed in their study was not the export of pentachlorophenol and its salts and esters, but this is more or less more than 90% the tetrabromobisphenol A and derivatives. Yeah. So you see also with scientific publications, sometimes you really need to go into details to understand. We come to second pesticide. This is endosulfan. So endosulfan has been listed in 2011. It was also a big product. More than 600,000 tons have been produced. So it had many exemptions at the listing, but now all registration has expired in 2019, and there is no production known and no trade known of endosulfan. Yeah. Here you see the production history of endosulfan. The main production was in the 2000s, but already here 2010s, it has decreased. And endosulfan got a own HS code from 2017 on. Yeah, and this is also from Zhou et al. So they checked here the HS code from endosulfan, and what you see here before at the major use, the HS code was not there. So therefore, no trade, especially for endosulfan, has been recorded in the Comtrade database. But then in 2017, the HS code came into play. And but at that time, the total production was less than 600 tons, less than 500 tons of endosulfan in 2017, decreasing to less than 100 tons in 2018, and then in 2019 there was also no trade and no registration. Yeah, so you see here for if the HS code is right, you have a specific HS code and you have the right chemical, then you really can understand from Comtrade database. For the dicrophol, the total production was around 240,000 tons. The last production stopped in India in 2019 after it was listed as a POP. So there is no exemption for the production and no exemption for the trade. So therefore, 4 years after production stop, probably there is also not much stocks left, and probably no and very minor trade, and also for this pesticide, no relevance today. When we look to the Decloran Plus, we see that in the past, only about 1,800 tons have been produced. The main production was in the United States from 1966 to 1975. In France, it has been produced until 1991. Main use, for example, in banana plantations here on some of these islands. Remarkable is that also you have a relatively small use overall. This is very, very persistent, this Decloran Plus, and today these islands are still heavily contaminated. No exemption for production and use, and also in the last 15 years, no trade has been recorded. The last pesticides listed are the different HCHs. First, lindane gamma HCH was a very big pesticide in the 1950s to the 1980s. Around 600,000 tons have been used. When it has been listed as a POP in 2009, there was an exemption for the use here for human health pharmaceutical use to control head lice and scabies. There was at that time no exemption for production. A little bit strange, but because the use for the pharmaceutical is so small, there was enough stocks still present from the last production in India, which was sufficient for this medical use. Also for lindane and HCH, there was a specific code already in 2004, yeah, because yes, Rotterdam Convention, so it was an early Rotterdam Convention chemical, so therefore we have information about the trade of HCH, and here it is not differentiated between lindane and the other HCH, so therefore you see, yes, around 2004, 2008, there seems still some larger trade, but then after listing 2009, there was hardly any trade. You see here 2015 a little bit. So this is what you see, this last trade for pharmaceuticals. But here from 2019 on, no trade is registered. The beta and gamma HCH are not interesting for the trade because they do not have pesticidal activity, no insecticidal activity. So here, what you see is that they were a co-product of lindane, of the gamma HCH. And for 1 ton of lindane produced, there was approximately 8 tons of other HCH waste isomers. So therefore, although there was no exemption here for production and use, we still have high volumes of these alpha and beta HCH from these old productions, because when you look here to the HCH production, it started in the 1950s, became big in the 60s, 70s, 80s, already 1990s decreased. The largest part is this alpha and beta HCH, yeah? And in most cases, this was not going into trade. Only the gamma HCH, the lindane, was going into trade. And this alpha and beta HCH, in many instances, was just disposed at production sites. Yeah, here you have a production site in Spain, yeah, where still today you have huge amount of alpha and beta HCH in landfills. Yeah, in total in this production site you have around 100,000 tons of HCH in landfill. What you see here, this is a former production site in Germany, former East Germany in Bitterfeld. And what you see here, this is not snow. This is alpha and beta HCH and how Germany managed at that time in the 1960s this waste into landfills, and these landfills are still existing. I'm a member of the HCH and Pesticide Association of John Fagan, who have worked on this topic the last 40 years, because this HCH was the biggest POP stockpile in the landfills of all POPs until the chlorinated paraffins came. And what you see here, this is the global map, and we estimated that in these countries, former production, 4 to 7 million tons of HCH, alpha and beta HCH, is landfilled. Yeah, you see here the major in Europe, yeah, but also here United States, China, India, Russia, Japan, Brazil, Argentina, and South Africa. Global assessment is needed because it is partly water soluble. It goes out of the landfill, and such assessment has been done in Europe. We had a project for the European Commission between 2020 and 2022. The European Union wanted to know all HCH and potentially HCH contaminated sites. And in Europe, we have about between 1.8 and 3 million tons. So we did an assessment in all European countries, and we found that we have around 299 sites which are known contaminated or are potentially contaminated because there were, for example, formulation of lindane in that site. And what is nice, the European Commission have put this map online, and you can go to this map and go to the individual sites and check the individual sites. There are activities of managing of some of these sites, but this is, let's say, one part which is in addition to production, trade, and use. Also, the final disposal is important for these POPs because they are not degrading in landfills and they are still there and are leaching. Last slide about DDT and a positive message. So the impossible can become possible. So there is an announcement of the last DDT production that by the end of 2024, with the help of UNIDO, the last DDT production is aiming to stop production by 2024. They say in the news that this was achieved by implementing alternatives like this Bacillus thuringiensis, who can be used to fight against malaria, neem-based biopesticides, and the manufacturing of long-lasting insecticides nets. So while the assessment of production, trade, and use of POPs is important, I mean, the message of this presentation for their global management and control, and for you, the most effective solution is to stop their production. And by this, I would like to end my presentation and a positive note. Yes, thank you very much for listening, and happy if you have questions on the different issues of this presentation.
Thank you very much, Roland. It was indeed very insightful and I think very explicit. And also thank you for adding the Decloran Plus and UV328, because these are recently added POPs. And thank you for updating the report. I think we do have 2 questions from the audience. So I will read one by one. One question is from Shimalis. Shimalis is asking, during compliance work in agriculture sectors, flower farms and vegetable farms, we have seen excess seedling growing medials, which are black, thick, and sooty. And when it is burned and the stock is much, until now, it is imported by farms, can we categorize them to the PFAS? I will share with you this question, or you can see it actually in the Q&A's module once again to review it.
I go in Q&A. Wait, I stopped my slides. I go Q&A.
So
go
the
to
question
chat.
from
Is it
Shima, yes,
Q&A?
it's a question.
Yeah, it's in Q&A.
Yes. It is a question from Shimalis.
I mean, with all these colors and so on, I mean, there are now some issues in respect to pesticides and PFAS. Yeah. I mean, you have seen the POP PFAS, which are used as a pesticide. So this was as insect bites, right? So, and when you look to the current use of pesticides, it is really more or less today only in South America. Before, also PFAS were used in other regions for insecticide bites, yeah, like for cockroaches and for ants. When you come into pesticides and PFAS use, so there are different PFAS uses where they are not active ingredients, but they are used, for example, or they were used as surfactants. Yeah. And there is one big issue in recent years in respect to pesticides and PFAS, which are the fluorination of the high-density polyethylene containers. So high-density polyethylene containers are partly fluorinated. And in the United States, the US EPA has found that the fluorination of these high-density polyethylene containers, that they can contain high levels of especially perfluorinated alkylated acids, carboxylated acids, including PFOA, the nona, the deca, so the longer chains. Yeah, and by this and the pesticide use, then the PFOA and the PFNA and PFDA are going into the environment. So the US EPA has taken action and actually prohibited the use of that fluorination of the pesticide containers. But it is at the moment a struggle, and it is a real big issue. So I have not seen, probably this might be done also in other countries, the fluorination of the containers, because the advantage is that if you have a normal high-density polyethylene container, the pesticides can migrate to some extent. Yeah, when you do the fluorination, then you do not have then you have solved the migration issue. Yeah, so this is the reason why it's done. So therefore, I think it's maybe not only done only in the United States, but maybe also in other countries. Yeah. So when you ask about pesticides and the PFAS worry, at the moment, this would be my biggest PFAS worry in the world, to check what other regions are doing in respect to fluorination of pesticide containers. Yeah. And it seems that this fluorination can be done in different ways. So there is one company which state that they can do a fluorination without producing PFAS. Yeah, but like I said, this is really a current issue of investigation. The US EPA has published own method for analysis and for extraction here of the PFAS from pesticide containers. You can just Google US EPA PFAS pesticide container, and then you will find the whole story. Yeah, it's very interesting, yeah, and very relevant. And it seems it's not only pesticide containers, but also some other plastic product containers are become fluorinated. So it seems that also some cosmetic containers are fluorinated, and also it seems there's a publication that also some food contact containers are fluorinated. But there I have not really seen data, but it is clear that this happens. Yeah, so let's say that's one interesting area in respect, especially then also the long chain. So before is listed, but when I'm also talking about the PFNA, the nona and the deca and the undeca and dodeca, yeah, acid. Yeah, so this is an issue of concern. Yeah. Does this clarify?
Yes, thank you very much, Roland. I think that was extensive. And for Shimelis who raised this question, please feel free to contact GGKP anytime later if you have any additional questions on this. And we do have one more question from Ibrahim Farah. So it's a little bit long, so I'll try to read this. Considering the critical importance of monitoring POPs, could you please elaborate on the current capabilities of our environmental laboratories in detecting and analyzing these compounds, and what advancements or enhancements are being implemented to ensure our testing infrastructure meets any proposed regulatory standards? And also, Ibrahim Farah added to the question that what specific actions or improvements can we implement to enhance our capability in detecting or analyzing POPs? And what vital surveillance and testing should be conducting to prepare document evidence or of their harmful effects, emphasizing the need for regulatory laws? Given the numerous published articles indicating the presence of POPs in various items, how can our lab effectively control and monitor these pollutants? Thank
Yes.
you. Roland, over to you.
Yes, I mean, the first thing, and what you already said, is to compile information of publications. Yeah, so that's, let's say, the first step, because so much has been analyzed, yeah, in different regions, and I completely agree that there is a lack of data, especially in African countries, South America, other developing countries. And often also the capacity is lacking there. Yeah, you can analyze the basic pop pesticides, yeah, but often, and now also PCBs capacity has been developed. But for the industrial POPs, I was telling in this presentation, there are hardly laboratories, for example, in Africa or South America, who can do the analysis. And when we come to the more complex one, like the PFAS and the chlorinated paraffins, hardly there's in Africa, I know in South Africa is a laboratory, but I do not know that there is another country which can at the moment analyze chlorinated paraffins in Africa. In South America, I also only know one which can analyze chlorinated paraffins. So here for sure there's a huge capacity building lag. You know, we have the global monitoring plan, and in the global monitoring plan there was also some capacity building on especially the basic POPs. This means pesticides and PCBs, but also not much capacity building on the brominated flame retardants. So this is for sure a big gap. I know that UNEP is planning the next phase of global monitoring plan, and I know that also UNEP aim that much more analysis is done in low and middle income countries. Yeah, before, let's say, the guiding laboratories were mainly from industrial countries. The advantage is, of course, you need also high quality laboratories that afterwards the data are for sure correct. You need a high QA and QC, and it takes years that for low levels, for example, in human milk, you have this QA and QC. But I know that UNEP for the next phase of the global monitoring plan is aiming to do more capacity building, is aiming to do more monitoring in the countries. When I supported meanwhile, I think around 40 countries for national implementation plans, yeah, including, let's say, action plans and so on. And we come always to the topic of action plan in respect to monitoring, yeah. And one thing what I recommend is really to do good regional networks, yeah. And that in the region you have a good exchange, and you have some laboratories at least which can do the tricky POPs. It cannot be established in all countries. That's impossible, because it's costly. Yeah, it's also costly for us, you know, this equipment, when it really comes to high-end chlorinated paraffin analysis or high-end PFAS analysis. The thing is costly. Yeah. So here, and I was happy, you know, there is every year the Global POP Conference. And over the years, for example, from Africa, the people have increased, and there is a network. Yeah. So there are many good African people which can do POP analysis, but often there are no laboratories. Yeah. So here, and this is a little bit unfortunate, the CHEF projects are only very rarely, let's say, supporting the capacity building and really the equipment in laboratories. So I have at the moment one laboratory in Ivory Coast, but unfortunately this was selected in a way that the people there were not really trained to do plastic analysis, so they were more toxicologists. So yeah, it is, you need more efforts from the countries, and we need more efforts also from the international community. The international POPs research community is certainly very much interested in capacity building in developing countries. I know activities from Europe, zum Beispiel Stuart Harrod from Birmingham has different research cooperations with Africa. I know from Germany, good research cooperations with South American countries, Spain, and China has activities globally for capacity building. I think this need to be a bit better coordinated, yeah, and also coordinated between research groups and governments, yeah, because yes, it is very expensive, and only, you know, if we do a good networking and if we bring the people together, that they know each other, and if the regions develop strategic their capacity. For example, you know, in Brazil, you have the regional center, which has been capacitated for all POPs, so also PFAS. They are analyzing now in Brazil. Also, you have the regional center in Czech Republic, which is doing capacity building and summer school, and is supporting the global monitoring plan. So I think there is already much there, but good that this becomes more coordinated, better networking, and that with the next GMP, more networking and more support for developing countries is happening.
Thank you for explicit answer, Roland. I think our Q&A module is full of questions right now, and also a lot of questions on the chat. So given that we have 5 minutes left, we have a question from...
Yes, we can answer questions, you know, yeah.
So we do have a question,
you know,
from...
we do not need to, yeah, yes.
From Katka from Reset Talks, how realistic do you see introducing labeling for products containing SCCP or other higher volume POPs that are still produced?
Yes, very, very, very good question, Katka. Yeah, I for the Secretariat, I had a small consultancy to write a report on the experience of labeling of HBCD, you know, and finally it does not became true. Yeah, so there were some activities, yeah, in Europe, yeah, and some options, but finally they have not really labeled the insulation foams. Yeah, I mean, a major reason for the insulation foams was, it is important to know afterwards that the non-HBCD containing foams, this means with the poly-FR, for example, can be recognized. Yeah, so the idea there was then maybe then we label the the new EPS XPS with does not contain HBCD, because otherwise we have huge amounts of unlabeled HBCD from the last 50 years. Yeah, and if we now use the new flame retardants and don't label, then we cannot separate. Yeah, so therefore the idea was then maybe we label the non-HBCD containing, but this finally did also not happen. Yeah. So the same there is an ISO standard actually for electronics. So in the ISO standard for electronics on labeling, you have a longer code. And in this code, there is one part of the code for the plasticizer and one part of the code for the flame retardant. So this started, I think, in the 2010s. Yeah. And so there was then a number also for DKBDE and so on. Yeah. So here for electronics, there is actually a system, an ISO system for the labeling. Yeah, which might or would work. But one thing is they concluded for the labeling that only parts which are larger than 100 gram are labeled. Yeah, because it is quite tricky when you have small parts to put the full label on it. Yeah, so yes, when it comes into the nitty-gritty, it becomes very complicated. I know that there are now new ideas. I think there is a kind of watermark, yeah, which is, I don't know, a kind of system where afterwards there is a small chip or something where you then afterwards can put information on that chip, on the information on that plastics. Yeah, so I think maybe with these new technologies, yeah, labeling of products might be possible also for smaller parts. Yeah, But until now, we have this only for electronics with the ISO standards. Yeah, and we will need more of this, and we probably need more technologies. Yeah.
Thank you very much, Roland, for explicit answer, and thank you, Katka, for the question. I think we can pick up one more question from the Q&A, and for the remaining questions, because we do have very many questions in the chat and also Q&A, so it would not be enough time to address all. But if you don't mind, Roland, we will address these questions after, maybe by email. When we share materials, we can provide some quick answers to this. So one question we have: with the production of DDT earmarked to stop by 2024, has the convention looked at the malaria prevalent regions when testing the alternatives?
Yeah, I'm not a DDT expert. I mean, I know that you had this DDT working group globally since the beginning of the convention, right? On alternatives. I also know that DDT is not the magic solution. I mean, there are also strains of mosquitoes which finally become resistant to DDT. Yeah. So therefore, also other pesticides would need to have been used. Yeah. And so therefore, DDT was also not the magic bullet. And when you look into the last years, I think there were only a very few countries, yeah, in Africa which have used DDT, while other countries which also have, let's say, the mosquitoes, let's say Suriname, since 20 years, they are not using DDT, they are using the alternatives. Yeah, but I know that also they can become resistant to the alternatives, and then you need to go to other pesticides. Yeah. But I also know that DDT was not the silver bullet. Yeah. So, but maybe you look into this. Let's say what I said. Let's say these alternatives. What India is now mainly using, but I know that there are other pesticides, a longer list of pyrethroids and so on, which are used. Yeah. But I also know that they are more expensive. Yeah, and that they are less persistent. Yeah. I know some pros and cons. Yeah. But after it's finished, it's finished, and it seems that there are so many countries handle malaria without DDT. Yeah, and I have been in a range of countries which manage it quite well. Yeah, and there are other major reasons when you look, for example, how car tires are handled, the breeding grounds, and so on. Yeah, so there are, let's say, also much other activities which a country can do, organize their waste management and so on, which will help to reduce malaria. Yeah, but I have to acknowledge I am not a DDT expert. Yeah.
Thank you very much, Roland. And this is totally fine. We would try to address the question a bit in more details and contact some colleagues from UNEP. So we will get back to the colleagues who raised this question. And also I see questions from Margaret, Ferdinand, and a couple of participants on the chat. Unfortunately, we are out of time for today, but we will address these questions as we recorded them, and we will get back to you by the email. And since we are very much out of time, and I think it's time for us to conclude, I would like to extend our gratitude to our speaker, Dr. Roland Weber. Million thanks for this great session. Thank you so much for your efforts to also update the report and include this recently added POPs, and for all the insights about the HS codes, because this is the center of this webinar, I would say, and we really appreciate it. I believe we derived all of us derived a lot from this session today. Special thanks to our project countries and all other countries for their participation. Many thanks to my colleague Samin for technical facilitation, and my deep gratitude to our interpreters. It has been a very technical session, I believe. Thank you, Jannike, Jolene, Eva Maria, Carissa, Tatiana, and Ilona. This was a great work. And
Thursday, next webinar, Thursday, yeah.
Sure,
will
sure.
be at least same interesting. Yeah.
Yes, Indeed, our next webinar is on 1st of August at the same time as this webinar, and we will share with you one more time the links so that for those who hasn't registered, you can register. For this webinar, recordings of this event in English, French, Spanish, and Russian, and the presentation materials, the slides, the report will be made available on our GGKP platform, but we will also share all the materials with you by email, and we will address the remaining questions by email as well. So we are looking forward to seeing you on 1st of August, this Thursday, for our POPs inventory webinar, the sectoral approach to POPs inventories. Many thanks to everyone for your active participation. That was really great once in a while, and thank you everyone once again. Thank you and see you.
Bye. Yeah, good progress in your countries. Yeah.
Thank you. Bye.
Bye.